Alright, time for another DraftScience video presentation. Mostly on the two-slit experiment. Lots of misconceptions in the world. Lots of bullshit. You have to keep arguing through it and explain how, a dog's anus doesn't have teeth in it. It doesn't, things that people see or think exist, and they're just made up stuff that never really happens, and blah 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 blah. So it's like, I don't know, I won't even try to compare it to something, but it's like somebody in their Bible stories and they're ingrained in their head, and you have to explain that, well, that's just a story, and maybe Jesus didn't make sandwiches for everyone, out of 3 pieces of bread or something. Maybe it's just a story, and maybe, he just had a lucky day and he just happened to have some extra stuff and he fed a couple of people and it just became kind of a big story when it really wasn't a story. Anyway, I was so bad at expressing myself in the last comment. Well, you're not going to do too good this time either. So this is Meskamoskos. Mos, something like that. Anyway, so I'll try again. Well, you should try it harder again. See, that would have been the thing. I will try betterish. Okay, with the double stripe, okay, I meant the situation when the double slit is measured at or before particle coming to the slit. I don't even know what you would be measuring before, but whatever, there's just no, yeah, sorry, I can't make any sense out of that. After that, it is stated by conventional physics that quantum state collapses. Yeah, I don't think it collapses until it actually hits the target, but okay. And we will see only 2 separate stripes in the screen. On the screen would be. But anyway, and no, that never happens. See, that's just an artifact of bad drawing. I've sort of pointed that out with the Feynman. They just draw it badly and they explain it badly, not the interference pattern. So there's nothing to explain because it's not a real experiment. That doesn't happen in real life. So I guess it's important to go over some of this stuff again. So often, let's almost say every single time. I mean, even Feynman does this part right. No one does this part right. So you go to draw the two-slit experiment, and you say, well, I have a light source, okay, and then a long distance away, okay, I have a little opening. So this is what Feynman does, a little aperture. And then I have the double slit. So technically, okay, this is included in most. Now, modern people take this one out because laser beams really don't need this. Okay, and all that is for is to make sure your photons, the long distance, is just making sure your photons are traveling in a straight line. They're not doing this thing and creating a projection way over there. So that's the idea. So the idea is that your photons are moving in a straight line. That's what the long distance kind of guarantees. The further away your light source, the more likely the photon that you're going to play with is going to be, and here's your target here. Which again, I have pointed out, mathematically you have to draw this way. Okay, that's what the math is predicting the pattern on this. Okay, not this. All right. Anyway, so I mean, there's so many misconceptions. Well, anyway, so this distance is for the very purpose of making the photons go straight. And what does that mean? It means that any pattern created by the two-slit area, right? This is only 1 millimeter. And it's still only 1 millimeter here at the target. So even if the target's a mile away, theoretically, this light, the light that actually goes straight, okay, is only going to be within a little 1 millimeter dot. So there is no, when Feynman draws hump number 1 and then hump number 2, didn't do that very well. Like that. Like, okay, there's 2 bright spots. There's a bright spot here and a bright spot here on the target. That doesn't ever happen because that is actually here, and these 2 are so close to each other. There's only a millimeter difference. So any pattern created by the 2 surfaces, there's only a millimeter of difference. So you can't see 2 separate headlights, so to speak. the two are so close together, the two slits are so close together that whether it's 4 sources or 2 sources, doesn't matter. They're so close together that any difference in their pattern is going to be so close to each other that you wouldn't be able to tell the difference. It's only 1 millimeter. Tiny amount of difference in their distances. So this drawing, when they did this stuff, when Feynman drew it like that, that's all crap. Okay, it never happens. There's no such experiment, blah, blah, blah. It's just bad physics. It's not very explained very well. And the key fact was this fact, the length of the distances. The whole point is to have these long distances for a purpose. The long distance here to the target is to magnify the image so you can see it. If you did the experiment really close, then it would only be a millimeter. You couldn't, a little tiny pattern. So you're projecting it because you're trying to take advantage of the fact that the fringes are actually being created by the surfaces. Okay, and the photons that go through the slit just hit this target straight over here. And the fringes are the ones creating, the surfaces are the ones creating all of the pattern. And all of the pattern is a divergence. And the further away you go, the bigger your view of the pattern. Obviously, the further away you go, the fewer photons are actually making your pattern in terms of visibility. So you can't go too far away or you don't get enough photons and you can't see the pattern. But the idea is you're magnifying with this distance, and with this distance you're collating, you're culminating the light. You're making it nice and straight so that it has purposes in terms of doing the experiment so you can actually see what happens. But there never is, the idea of I'm throwing baseballs through 2 slits, and the baseballs just end up going dot, 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 and dot, dot, dot over here. There's no dot, dot over here and dot, dot over here. Okay, there's just, 1 millimeter of difference between the two patterns of dot, 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 dot. So it's it all looks like just one pattern of dots. Technology failure. Chalk dispenser couldn't handle the dotting. Anyway, so there is no, there's a hump over here and a hump over here of stuff. That never happens. It's not part of the real story. Yeah, it's probably enough on that particular statement, right? I mean, any quantum stuff. So we probably should redraw this. What do I do with the eraser? I don't know. Anyway, okay, we'll just go back for a second. I don't think I need to do the quantum part yet. But, all right, continuing. He says, does your 2 by 2 by 2 bit model predict that too? So obviously it doesn't predict it because it doesn't actually happen. You can make these arguments with headlights from a distance on a car. At a certain distance, you can't tell there's 2 headlights anymore. It just merges into one. And it's the same sense, the effect here is the point is if I take 2 laser beams and I just have them 1 millimeter, 1 millimeter of distance, I'm shining them on the wall and I only have 1 millimeter of distance, all I'll see is one blob. I won't see 2 laser beams. It'll all just get blended together. So it doesn't happen. You can't have a slit experiment with light and create 2 stripes. The 2 stripe thing never happens. It's not a real experiment. Okay. And so you don't need the 2, 2 plus 2 plus 2. Yeah, you have 2 minus 2 minus 2. Anyway, 2 plus 2 plus 2 model, okay, to get the part that you're just defining what the energy is differently than what conventional physics has it as. The idea is that a photon isn't a blob. The photon is a composite object. It has more than one element to it. Photons take time to create and they take time to land on a surface because they're more than one event. There's more than one event to a photon. That's a key thing to understand. The difference in the model. It's like the difference between a model that says 2 things are here and they hit each other. One model could say this is the models discussed by Newton and Leibniz, back in the 1600s were these kind of arguments. does it happen this way? They both go off together. Or does it actually happen this way, where one leaves and one stays still? See, Leibniz had a theory about how motion is conveyed between objects, but didn't make any sense because it basically relied on this. It relied on something that the motion is cumulative, that you can, you hit something and they both go off at the same speed, when that doesn't happen, or even at a reduced speed. The fact is you can't multiply the movement. You have to degrade it. So if it's a reduced speed, then you can understand, well, it's constantly being reduced when it hits a big object, because it's, the two thing is moving half the speed of the one thing, and so then when it hits another thing, it's going to be a third of the speed, and the speed just keeps reducing and reducing and reducing. So I'm just saying it has to do with what you can't view the outcome from a multiple of wave particle duality thing. You can't think of it as a particle and a wave and a banana peel. If you're going to think of it as a bunch of different things going in, you can't model it. You have to choose, to believe something for a moment and say, what would happen if, it's just that, that this is how energy is transferred. What happens in the universe? And then you model that separate from the other model. I'm sorry, I mean, being patronizing, but it's, you can't include all of this stuff without getting these. You have to be careful about your axioms, your premises. And so the first thing you have to understand is that there is no stripes. There is no, I'm throwing baseballs through two giant slits and creating two giant patterns on a wall. I'm not doing that. I'm throwing baseballs from like a mile away, to be fair to the light experiment, at two slits very close to each other, and then I'm receiving them miles away, in terms of how they've been changed. All right. So the photon level, as I pointed out, so you have to understand, I guess we'll get to the scatter thing first, and understanding what the motion is about. So I've done this many times in videos, but I move my hand really fast. If we could imagine I could move it at the speed of light, it would actually be collecting every photon that's coming from the light. Every single photon would essentially be now at the same location. I would be collecting every photon that was coming towards my hand. Every single one of them would now, instead of coming at different rates, my hand would essentially be collecting all of them as reflections, but none of the reflections could leave because my hand's moving the same speed as the reflecting photon. So as my hand moves the speed of light, it would collect every single photon and deliver them to you all at once. So it would collect all the energy that's in the universe, potentially reflecting off my hand. All of that energy would be collected and shot at you. And the inverse happens from my perspective. As the hand leaves me at the speed of light, nothing comes back. I don't get any energy back. No reflections at all. Very quiet. So you have to think of the electron as sitting in space. And you can think of it as an ether if you want, but it's not. But it's in a sea of these little pieces of energy. This force stuff moving the speed of light. It's in a sea of it. And every time it moves this way, it sends more bits that way. Every time it moves this way, it sends more bits that way. And it moves because it gets hit by more bits from one side than the other side. So it just, when energy hits it this way and moves it, it sends the energy as a reflection that way. The actual energy doesn't go that way because the energy is actually a degrade in the energy in the force, because this can't move quite the speed of light, but it moves fast. Fast enough to create a difference in the reflection. So when an electron is moved, it's creating a frequency in the universe. So when it moves and then stops because it drags to a halt, it hits more stuff coming at it, so it slows down and stops. and then it's caused to move back, or because it's in an atom, it's going to move back because it's an elastic creation. The pieces are connected to each other in the sense of force between them, pressure. So when you move an electron inside the atom, now the electron doesn't want to stay there because its relationship to the proton and the other electrons is an established relationship, and there's going to be a will to go back. A will, wrong word. There's going to be a force differential that's going to make it want to go back. Make it go back. No wanting involved. And when it does that, then it's going to create the opposite thing. It's going to create more pressure that way and less pressure that way. And so you can see that your on and off, and on and off isn't really a complete off, and it's not a complete on. It's just extra, less, extra, less, extra, less. See, do I really need to draw that any further? Yeah. So I can do this much to explain. So when I say scatter, what am I saying? I'm saying there's an electron in a position, okay, and it's in an atom, it's connected to the atom, other electrons, the proton, all of that's happening. So it's in a circumstance where it's there for a reason, okay? It's bound by some energy. It's not just sitting there doing nothing. It's in a relationship to the matter. So the matter has a relationship to the electron. All right, and you hit it with your little extra piece of force from this side. So you're changing the balance. It's getting hit by a certain amount of rain this way and a certain amount of rain this way, and you're changing the balance now. You're shooting a photon, so you're adding more energy from this direction. And one of the pieces of the photon, right? The photon is this. One of these pieces, let's say this little fellow, comes around and it's going to hit that electron. Well, what it's going to do is it's going to push the electron to a new position. Now, the likelihood is it can't go straight because the electron is bound. And so the tension of the electron, that is the pull and all that other stuff, is either going to pull it down this way, or it might push it where the electrons repel each other out this way. And it just depends on where its position is relative to the other electrons and the proton. So depending on what its state is, it can either go this way or go this way. And that's the key to the whole thing, right? Because whatever direction it goes is what's going to be considered the new energy, the energy of the electron. So I've changed its position, and now it's in a place, okay, where it can't be sustained because its forces aren't going to be sustainable. But the point is, it moved to that position. It moved in this direction. That means it reflected more energy in that direction. So the energy that came in reflected this way. Okay, so energy came in and reflected this way. So I've changed the extra energy from this way to this way. Or, like I said, it could be that way or that way or that way or that way. It just depends on the state of the electron. You're combining the electron's momentum with the photon's momentum and coming up with a new vector of momentum. And the new vector will be a reflection off the electron. What happens to this is sort of irrelevant now, but whatever. That's the new vector of energy. That's where the added reflection is going, the added energy. A piece of energy was going this way. It was supposed to hit an electron, say, back here, right? And it didn't, because it hit it here. By hitting it here, it has more energy because it's coming back sooner. You can sort of get that. It's a shorter path. And shortening the path is essentially the same thing. If I shorten something's path, because I don't bother with this part and I just do this, if I shorten the path, that's the same thing as increasing the velocity. So for a photon, its energy in any period of time, like any 4-second period, is completely dependent on how long its path length is. If I shorten its path length, then I've essentially increased its speed or its energy, because now it's moved this from A to B, okay, in less time because it didn't do this stupid thing. If it does this stupid thing, then technically it's moving a lot slower, okay? I mean, technically it's been degraded because it didn't get from point A to point B in the short amount of time. It took longer. Alright, so that's sort of the way you have to understand scatter. Scatter isn't technically this bouncing off of the electron or doing something like that. No, it's this combining with the electron, creating a new vector, a new direction of motion for the electron, and that motion is going to cause energy in the direction of the motion because it's going to cause quickening reflections. It's going to cause reflections that are going to happen sooner than they would have happened otherwise, and if they happen sooner, that's the same thing as more energy. And the inverse is going to happen. When the electron moves in this direction or this direction, there's not enough energy to force it out of the atom it's attached to. So what's it going to do? The forces of the atom are going to end up just causing it to move back. And when it moves back, the exact opposite is going to happen. So you're going to have a little bit of extra energy, so I shouldn't use a plus sign. Extra. We'll just use an E. Well, it doesn't really work either, but anyway, you're going to have a little extra in the the soup. You're going to push some soup that way, and then when I go back, when the electron moves this way, it's going to be pushing less soup, so there's going to be the empty spot, and then you could push again, and then you could have an empty spot, and then you could push again, and then you're going to have an empty, and see, this is the photon, this is the pattern you're creating. But a single electron doesn't create the photon. It takes numerous electrons in sequence to create this thing you need, the on off at specific intervals. But in essence, what you're doing is the phase, the order that this little bit was in from this photon is still maintained, because even though you've delayed it a little, that's the same as just taking it out of phase a little. So what? If you take it out of phase a completely one wavelength worth of distance, then you'll be in the same order as you were before, the same phase. You'll just be, the third bit is now the fourth bit of the photon, or the fifth bit. So any delay doesn't necessarily mean the photon can't be reconstructed. It just means that you have to, either delay everything, or you have two different photons and use the pieces from the different photons. I can have 3 photons go through a system, and I can use this one, and this one. So these 3 photons will create this 1 photon, if you get me, because they'll come at the right order. So even though these photons were in different order, they came at different times, I can use the last element from one, and the first element from another, and the middle element from another. I can combine the pieces that are in the right sequence. Anything else to say there? So you have to understand, scatter isn't scatter like the photon that hits something isn't the photon you're going to receive, not in composite bits or in time. And that's what you have to understand, is all you're doing is causing motion in the universe. The motion in the universe will cause a change in the reflection. The change in the reflection is going to be the new photon. Alright. I think good enough for you to maybe get it. I don't know. Alright. So, the second thing I wanted to ask is so I really want to get back to this conventional physics, the quantum state collapses thing. So, the quantum state only comes up because they have to explain this in terms of single photons going through the slits, because they have an assumption that a single photon can produce the pattern, and it's just an assumption. There's no real evidence that that happens. So they make up this story, and again, the story doesn't really work with a single slit, because you can't really say I send one photon into one single slit and somehow it creates 2 vectors, 2 waves. It can't do that, right, rationally. And there's no excuse for 2 waves. Now again, I've also explained that in the double slit, okay, the 2-wave theory, the Young drawing of 2 waves coming out of the double slit, that math fails. Okay, it fails. It doesn't get the right answer. Now sometimes it's close, it's pretty close. Oh, instead of here it's here, it's a little bit off. That's if you make the slits very tiny, or you make the single impediment very tiny, and that way you can change the amount of distance there are between the surfaces. If I make the slits tiny enough, the amount of difference between this surface and this surface becomes so minuscule that you can't really tell the difference in the effect. The change in the diffraction from here and the change in the diffraction from here is so slight because of the distance is so slight that I can't see those headlights as separate headlights. So that math can the insufficient, incomplete math can get close to a right answer when I make things really, really thin. But if I do the real experiment, okay, at real proportions, the double slit math of two waves, two vectors, fails, gets the wrong answer, doesn't even get the double pattern, okay? And the only way you can get the right pattern is to count all four surfaces. So all four surfaces are vectors. They're where the vectors come from. That's the geometry. And that's the math that will give you the right answer. It'll give you the right answer on a curved surface, of course. So there is no quantum state. There is no superposition. All of this stuff is babble. Forces don't interact with forces. Gravity doesn't bend light. None of this nonsense is in any experimental proof for any of it. Okay, it doesn't exist. It's just crap. I've already been over the lensing images. The galactic lensing images are mathematically a nightmare. They're so bad. They're not even close to being the perfect geometry they should be. Space has 400 times better resolution. Space is really, really exact. And yet those images are all over the place mathematically. They're a mess. And they shouldn't be. They should be clearer and clearer. They should be more and more explicitly spherical and all of that kind of stuff, not less and less. So, anyway. The second thing, look, in the quantum state, the collapse of a quantum state, as I've pointed out before, if you understand that the electron is, in fact, that gravity is an actual force, and that the electron is constantly being jostled, and the photons, everything is in a sea of energy, that there would be no way for there to be any collapsing state, because every tiny millisecond of time you're getting hit by something, and getting hit by something is the same as whether we send a photon to take a picture of something, or whether the universe sends a photon and bounces it back, makes no difference. If one event collapses the photons, then the other event has to collapse them. So there is no state where you get to go through the experiment without hitting any energy. And so you're in some superimposed state and you never get collapsed until you hit the target. There's no, I didn't hit anything on the whole trip. No, you're hitting something constant. It's like saying I can drive to the store without hitting any air. You can't drive to the store without hitting any air. Okay, it's just total nonsense. You're going to get collapsed as soon as the first little air molecule hits you. Anyway, it's just a silly story. These are silly explanations. I really shouldn't have to work this hard to get you to say, oh yeah, I get it. Bent space is not an answer. It doesn't tell you how it happens. It doesn't tell you why the electron moves. It's nothing. It's crap as an answer. It's just magic. Superposition, entanglement. I mean, these are nonsense concepts, and they have really nothing. They have no good evidence for any of this crap. They have convoluted equations and convoluted experiments for which they have made a ton of stupid assumptions like, well, there'd be two blobs, if it wasn't for this special entanglement interferency thingy. When there wouldn't be. It's just a wrong assumption. All right, the second thing I wanted to ask is that how would X-rays or gamma photons behave in the double slit experiment? They behave the same way, but their pattern, the distance between them is now tinier, okay? So a fraction. And so now it's a lot harder to see the pattern because obviously the distance between the bars and the size of the bars is going to be much, much smaller. And that's going to be a real problem. And then the other point to raise is that you have to make materials now that are impervious to X-rays. So you have to make the slits out of steel or something, blah, blah, blah. So it gets a little more complicated. If you used a scintillator and photomultiplier, so again, a scintillator is for muons as far as I understand, but it might be a general term for things that cause a reaction to events, and then they make it seem like they didn't put a catalyst in. Like the scintillator is somehow a special kind of catalyst that doesn't have to change anything to change everything. The scintillator is the thing creating the photon. The muon didn't do it. That kind of thing. And the photomultiplier on the detector side. So obviously it helps to use technology. You wear your glasses, you can see better, that kind of thing. So it doesn't hurt to use a device that's capable of seeing better. But that's the trick. You can use a photomultiplier and all of a sudden you're detecting photons that don't really exist as visible photons. You're detecting all kinds of photons, infrared, all kinds of stuff. And that is going to produce noise in your experiment and blah, 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 blah. All right. Would they produce double stripe? So again, double stripe can't be produced because if it was produced, it's it's a tiny, tiny, tiny. At 5 meters of distance, it's still 1 millimeter. You can't see the stripes because they're so close together. So it's impossible to view them because your slits are so close, so tiny. All right, and in the case of of X-rays, again, you're talking about 100-fold, change in the size, a tiny, tiny slit. What would be the effective wavelength? So again, this effective wavelength, baby talk, this is all bad physics in my opinion. You want me to explain to you every de Broglie mistake? Frankly, there's no good reason to believe that photons electrons have a wavelength or anything else, and that all you're saying is it's just a time period between events, and that X-rays, the time period is more quickly. It's the same stuff being thrown, same baseballs, you're just throwing them quicker. And the slit width ratio to produce either stripe or interference. So would they produce double stripe, or would it be effective wavelength and slit width ratio to produce either stripe or interference? See, I don't know what you're asking. These are really so poorly written questions. What would be the effective wavelength? It's not an effective wavelength, it's a real one. X-rays have a real wavelength, okay? They don't have an effective one, they have a real one. Electrons have an effective wavelength. School buses have an effective wavelength by nonsense physics. All right, anyway. And the slit width ratio to produce either stripe or interference. Well, again, the slit width has to be mechanically impossible for us to make the slit width, right? And unless you're talking about microscopic, stuff. And you can sort of know that as soon as you get into that, you're getting into real irregularities where now it's going to matter which way the atoms are lined up on this. You can't even make a cut line. At those dimensions, any irregularities in your cutting device are going to become more and more exaggerated. And so you're not likely to get a very clear pattern. Anyway. And the third one, would optical photons scatter to all random directions? All right, so the directions aren't random. They're definitely going to be coherent to the fact that the electrons are on a surface. So let's understand this is why the slit experiment works at all. Wouldn't work at all, okay, with just some sort of like scatter in the atmosphere. So the difference between an atom just flying through the atmosphere right now. Okay, there's a little atom and he's just getting jostled around. He's hitting stuff, bouncing, blah 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 blah. Bouncing around, blah 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 blah. He's going in any direction. So he's going forward and back. He's going up and down. Okay, and he's going left and right. He's doing any one of those directions. An electron bound to a surface is going to do this or this. It's not going to do this and all that other crap, because the way it's going to be tend to be distorted in its movement, the limits on its capacity to go in a direction are completely tied to its magnetic connection to the surface. So it's like there's a string tied to it, okay, that makes it go this way. Alright, so it doesn't have anything to do with going this way or any of those other directions. This way is the way the string is attached. And your photon's coming in straight. So, you know, let's see how to draw that exactly. So the electron is here on a surface. It's not going to move this way or this way when you hit it with a photon this way, right? So you're hitting it with a photon into the board. Chalk failure again. Anyway, and it's going to swing on this arc, essentially. It's what I'm saying is it's going to either go into the surface or it's going to go out. So it's going to go this way or it's going to go that way. And so that's why the pattern works, is because you're basically making the slits long. So you're getting rid of this surface as being a problem. So very little light is hitting up here and going up or down, you know, getting curled this way or getting curled up. And the primary part of the light, you know, your laser's hitting like this. You want it, so the real effect is you're just really hitting electrons this way, bound in a system that's going to make them swing like doors. And the electron can swing, you know, it can swing that way or it can swing that way. And those are the two ways it can be changed. When you hit the electron will either go into the surface or it'll go out of the surface. And so any one of these vectors is possible, including the straight line vector. So this gets to his point in a minute. Alright, so the straight line vector is also possible. You hit the electron and it happens not to be moving at the very moment. And so it just transfers the energy in the same direction the photon was going, and the bit goes perfectly straight. That's also a possibility. But the point is that you have what's really happening. The real pattern of the double slit is this, right? You got surfaces, and what you basically have is here: scatter, scatter, scatter. In terms of which way the electron could the added energy. The two energies will be added together, and this is what you'll get. And that is essentially the same as this being waves, right? So I could wave it, but then the wave has to break here in the middle of the opening, and somehow the wave has to go, you know, the energy has to go right through the material. So obviously that wouldn't be a sensible thing to call a wave center. And it's just much more sensible to understand, no, it's a center, it's a focus for the scatter. The scatter will be in these directions. Alright, any one of them at any one particular moment. And that creates all of the fringe pattern. So the light in the center, okay, is just being created by whatever photons can get through the slit. So if you make the slits wide enough and a whole photon, that is the whole pattern, can fit, then you get light hitting the center. Okay. And that's all inside of 1 millimeter. 1 millimeter. And obviously lasers diverge a little bit, so it's going to be a little bigger than that on the target. And all of the fringes, all of them, every single bit of light that goes here or here, is being created by the light that went by the surface. So make the slits smaller and a higher percentage of the photons will go by the surface. Make the slits wider and a fewer percentage of the photons will go by the surface, and the pattern will get less and less visible because the number of photons that are hitting the surface will be, say, 10%, right? And you have 90% here. You're not going to be able to see this. It's going to get duller and duller compared to the amount of light being produced by this. So the pattern becomes more and more less and less visible. And the more you change this ratio, that is, the smaller you make the slits and the fewer that get straight through without getting disturbed, without hitting an electron, then those percentages become more realistic. If you have 50-50. And clearly when you get 90-10, the inverse way, the pattern becomes very clear. And it's really all pattern, and no whole photons are getting through. Alright, and the third one. Wouldn't optical photons scatter to all directions from electrons and thus produce shadows rather than interference? Right, so there's no shadow. There's no the energy bounces off the electron idea. Okay, eventually it does, but it does because there's an equal and opposite reaction. That is, something hits from the other side and they both reflect. But you really don't need to understand all of that to understand it's the motion of the electron that's creating the new photon. So you're hitting the electron with energy, causing the electron to move, and when the electron moves in a direction, it's creating a potential photon by creating a thickness, in the energy field, because it's causing more reflections in a direction, or the empty spot. I mean, both are essential. It's essential to create the more stuff, and it's also essential that you create the less stuff to compare it to, all right, to create your Morse code. And the fact is that all the matter is constantly cleaning, filtering. So the noise is filtered out by the object because it says, well, I got hit by 50 things this way and 49 things this way. I go one. It's constantly doing the math. So it's filtering out all of the stuff that balances, and all it's really going to transfer by moving, when the electron is basically saying there's an imbalance. It's not saying, it doesn't care whether it's 99 to 98 or it's 99 to 1. It just cares that there's an imbalance and it's going to move in that direction. As soon as it moves in that direction, it sends a signal in that direction saying, I've been hit by more energy, there's more energy coming towards you, here's a new version of it. It's just going to send a reflection that's going to be essentially the force that initiated the reflection. It's just going to be delayed by a little piece of time. Yeah. All right, so I think that's the best I can do. So there is no scatter. Isn't you can't think of it like you're shining light on a baseball. That's not what's happening. Light isn't reflecting off the baseball and not moving the baseball. You have to think of it in terms of the baseball's moving, and it's moving inside a system that's full of energy. So when it moves, it pushes more energy just by moving. Is there some other way I can analogize that? So scatter isn't just BBs bouncing off at angles or something, and they can only bounce, they can't go through the electron, therefore it creates a shadow of the electron. You can't make a shadow of the electron out of photons. That's not going to happen. And the only fact is that the electron is very unlikely to be stationary, that is, not having any jiggle at the moment. It's not going in any one direction, it's quiet. You're not going to hit a quiet electron very often. So most of the time the electron will have a momentum in a direction, and your element of your photon, your piece of the photon, will hit the electron and the two combine. And that's the new vector for the photon, essentially. Yeah, that's the best I can do, I think. But it's going to be made out of reflected light. The scatter is a reflection to the universe. So even in the big universe, when there's scatter, like the atmospheric scatter, the same thing is happening. The electron's getting hit by the element of energy in the atmosphere. The electron is moving in a vector dependent on which way the atom was moving, and that's the new direction of the photon. And the delay is essentially the subtle frequency shift you're going to get with Compton scattering. For example, you'll degrade the frequency of the light a tiny, tiny, tiny little bit, okay, each time that event happens, because the fact is the electron won't be moving as fast as the speed of light. So the added force in the direction is not as strong, let's just say, as the initial energy, because it's really, I don't want to get into energy comparisons. we're just remaking a pattern, but you're remaking the pattern slightly delayed from the first pattern. All right. So probably enough of a video. I'm surprised that people have these many misconceptions after I've done so many videos, but yes, presumably they haven't watched enough of them. So I'll point out again that there's 3 specific videos on each one of these subjects, photons, kinetic energy, and gravity. And those 3 videos have a lot of this in them. A lot of these facts that you need to appreciate if you're going to understand why there's a better model, one that really works well, and their model really works badly. It's incomprehensible to start with, and it doesn't even work. I mean, that's the more important part. And it's just so overtly based on bad chicanery evidence. Again, to bring up the Young experiment and to talk about Young is just such a crime against physics, because Young's analysis fails to get right answers. His image of the double slit was so bad, he didn't even see the real pattern. So how, and again, it was so bad he couldn't possibly do exact measurements to find out that his two-wave theory doesn't work. It doesn't get right answers. It doesn't predict the position of the bars or the size of the bars. It gets the answers wrong. And for them to keep talking as if it gets right answers when it's overtly wrong answers, I mean, how many of their little crimes against, fairness do they have to commit? Right? The Eddington experiment, I can keep bringing it up, and then they'll say, well, we've done other experiments to confirm Einstein's 2x prediction. And what do the other experiments all contain? Scatter. They're scattered light, okay? They're experiments that involve going through the corona of the sun, shining a light bulb, shining light through the thick, soupy part of the sun. Of course that light gets bent, and it gets bent in all directions. So that is, some of the light takes a very short path around the sun, right? So I mean, they're using experiments that are so obviously flawed that you just gotta say, what the hell? Come on, how do they get away with this? So the Eddington experiment's only, it's a pure way to see whether or not this light bending thing happens. But if you shoot light through the corona of the sun, okay, this part, there's lots and lots of electrons in here. So you're going to scatter. Whatever photon goes in, it's going to scatter. It's going to change its direction, every single one of them. And the trick is that if you're trying to measure, a bend, right, the light's going to bend. Well, yeah, it's going to bend this way from scatter, but, say it was coming in this way. But it's also going to bend this way. It's going to bend every single place. So there's going to be places where the path length is a lot longer, and there's going to be places where the path length is shorter. And, from here, say you're here, located here. So yes, you will get light at that location bent, but you're going to get it at this location, and you're going to get listed. You're going to get every single location you could pick. You're going to get the shortest path to that location because some of the scatter will go that way. So it's inevitable that you will, look, it's magic, it took the shortest path. Well, no, it also took the longest path. It took every path. Okay, you're only going to get a tiny percentage of, they're getting they're sending, whatever, 1,000 watts of energy here, and they're getting, 0.0001% of the energy back. And then they're making these claims. Well, obviously, all the rest of the energy is in all these other locations that are completely demonstrating no such 2x bending. All right. So whatever. I mean, there's doing this physics things. There's lots of little subtle details, but there's really not that many. And and this really should be a conversation, people who have some mechanical experience in the world. You know, people that can, you know, park their car. You know, people that can do, you know, pour Coke into a glass without spilling it. You know, do basic mechanical things. They should be able to get this. Yeah, this really shouldn't be this big a problem. Anyway, so I think that's enough. And so we'll call it a video. So till the next time and such and so forth and whatnot. Blah, 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 blah. As I'm known to say, hey, it didn't work. Keyboard's not getting a signal. Apparently. There, now it worked. Okay, so till the next time and such. This has been a DraftScience video presentation.